Welcome to the lecture. Today we are going to see a case study on charging and discharging behavior of electric vehicles. So welcome to the lecture. So in today's case we are going to discuss about one of the vehicle which is manufactured by Tata, right? So here the Tata Punch is the vehicle we are going to discuss for this case, right? So our case is that the user, the customer is having two electric vehicles. One is Tata Punch and another one is MG Zetas EV. So both are run by the couple, right? The husband and wife, they own each an electric vehicle. So what happened here is they did not follow the charging rules. And what happened here is once the battery reaches 60 or 70% from 100, the Tata Punch is keep on charged, and it is not maintained till 100. So this is what the case.
So in this case study, we are going to discuss about the what are the charging behaviors followed by the couples and what are the remedies taken from the OEM to rectify the issue, how they have tackled the issue as Shar told us, and next will be taken by the Surya Prakash.
Hello everyone. Before that, we need to know the basic temperature condition of a EV. Basic temperature of a EV is around 25 to 45 degrees Celsius. While charging the EV, the temperature is around 78 to 80 degrees of Celsius. Overcharging of an EV, which can lead to the overheating of a battery, and which leads to an overcharging or over discharging of a battery cells, and which reflects in the vehicle performance and battery discharges. To notify the overcharging, there is a sensor placed in an charging near the charging compartment, which is overcharging alarm.
Hello everyone. So let's include a alarm system for a vehicle while charging and discharging. We need to stop charging in a certain percentage. We can set it into the 30% minimum, and then we need to plug out in a correct time. It is 100%. So now we include the alarm system. First we need things like sensors, temperature sensors and voltage sensors and other production sensors like smoke sensor and some sensors for the production. So these sensors are connected with the ECU, and also we have one main system that was a battery management system. The battery management system also connected into the ECU. Now we can feed a ECU that alarm system will alert V when charging is discharged into the 30% and then charge are reached into the 100%. So this algorithm will work while charging and discharging. The system will monitor the battery lively. If battery gets into the 30%, the alarm will alert us to charge the battery, so we can know that we need to charge the battery, and then the alarm will alert us when charge is reached into the 100. We don't need to charge after the 100%, so we can know we need to black out the charging while battery get 100% charged. Thank you.
So I am Ashwin. Now I am here to explain about the components and the materials used in the heating control system used in the BMS. The first component is a smoke detector, and the second is a voltage sensor, and third is a current sensor, and then fourth is a temperature sensor. And then there is an electrical control unit where we connect the output from the sensors and to the electrical control unit, where the electrical control unit output is connected to the vehicle control unit, where then the actuators are done. For example, if there is a smoke or any temperature increases in the battery pack, the battery management system detects that data from the sensors collected. Then the ECU converts that signal into a digital signal, and then the signal is processed and then processed to the VCU, vehicle control unit. Then the vehicle control unit has an already already fixed set of amounts of data, where it compares the already given data with the new data. If the already data exceeds 100 degree or some extreme temperature, then the collected data, new data is matched. If that matches, then the output will be the dangerous or any extreme situation. So that the electrical control unit or vehicle control unit give a actuator. For example, it can be a signal or a message notification or a charge cut off system, where then the charging or a message notifications will be sent and the battery management system is brought to the normal.
So as we discussed about the managing this issue, if we see here, not only the battery or the charging, right? So the user must be well knowledgeable person on how to use the system. That matters a lot, because if you charge or discharge without the prescribed things, what will happen is the battery will not behave to its 100% efficiency. So this is what the major impact, right? So in this case, if you see here, the battery is charged when it reaches 60% from 100, and it is again removed from the charging when it is not reaching 100%, right? Without reaching the charging 100%, the battery is the charger is removed from the source. So what happens is the battery cells are not balanced. Once the cells are not balanced and the batteries keep on charging in the, like this cycle, what will happen is the battery will not behave to its 100%. So as we discussed in this lecture or the case study, if you see here, we must design, the system must not allow the user to unplug the charger. That is the main thing. And once it is charged, the system must ensure that all the battery cells are managed. So this is how the system can be used. And another thing is, when the system reaches critical temperature, other subsystems like battery management system, cooling system should be enabled, and it should be monitored continuously in order to maintain the system in a equal state. So this is how we can avoid firing of electric vehicles, as well as to maintain charging and discharging as per the manufacturer's recommendation. I hope this lecture gave you some eyesight on how the usage of charging and discharging, and through this case we come to know how it can be rectified. Let us meet in another lecture. Thank you.
Thank you.